Alright, in this section here we're going to be using the quadratic formula for finding the solutions to a quadratic equation. So in the previous sections we did this by completing the square. Now I'm going to, we'll just start off with writing, for example, a quadratic equation, 2x squared minus 11x plus 5. Okay, so we were able in the last section, we know now how to complete the square to solve for x in this problem. But hopefully this formula that I'm about to lay out, that you've probably heard of, nightmares of. I showed a girl this one time, and she started crying and told me that she would never be able to learn this. And there was another girl that was sitting to my right. It was in a math lab, and she looked at me and told me that I was really mean. I was a mean person. I'm telling her that she was going to have to memorize this. Well, the best way to memorize this is just work problems over and over again. Okay, and you keep writing this over and over again, and you'll eventually get it. Well, where in the world does this crazy thing come from? And that's about what I'm about to derive up here. So unfortunately, you're going to have to watch this before you can actually watch how to use this by just taking this guy right here and plugging it in and getting your solutions out. We're going to do this by completing the square. Okay, by completing the square, and I'm going to need lots of board space for this, so I'm going to clear that off. And it looks like I cleared everything off. Alright, so generally speaking, we're solving this right here. Ax squared plus bx plus c is equal to 0. Now we must state that a cannot be equal to 0. Now what I'm going to do is I'm going to take this and complete the square. So remember, we need a 1 right here. Okay, so I'm going to factor the a out. So we end up with b over ax plus c over a, and that's all equal to 0. Okay. Now, we go through the same procedures we've gone through before on completing the square, except we're just working with letters here. So you just run through the same procedures. So this becomes b squared over 2 squared is going to be 4, and then a squared. Alright. So I'm going to rewrite. So we're just following these exact same procedures. We underline, put a blank here, then plus c over a. So this b squared over 4a squared, I'll use that as my fraction bar there, and then minus b squared over 4a squared. Right? And let's just close up that parentheses. That's still equal to 0 there. Okay. Now that looks sloppy. We'll go ahead and rewrite this a. Alright, so we're now going to have, let's see, I'll start another parentheses, x plus, remember we take a half of this, so this is b over 2a. We square it, and then we say plus, and now we have this guy right here, and we need to get that all into one single fraction there. And so what I'm going to do is just do a little side work over here. We have c over a minus b squared over 4a squared. So I need to multiply the top by 4a and the bottom by 4a. So this way we have 4ac over 4a squared, so we have a common denominator, over 4a squared, and then of course we can now get all that in one single fraction, 4ac minus Alright, and let's see. This would be all over 4a squared. So we're going to go ahead and take this 4a squared, or this piece here, and now plug it in here, right? So this was now all reduced down to a single fraction. So we have 4ac minus b squared. That's all over 4a squared. Okay, and then of course I need to close up this parentheses, remember, and this is all still equal to 0 here. Alright, so hopefully you're not lost. Okay, so now what I'm going to do is I can multiply both sides by 1 over a. That just drops the a completely out right here. Okay, so that'll drop that a completely out. So I'm going to rewrite this now as x plus b over 2a, that's squared, plus 4ac minus b squared, that's all over 4a squared, and that's equal to 0. So now I'm going to take this piece over to the other side of the equal sign. So this becomes negative 4ac minus b squared over 4a squared, and we have x plus b over 2a, and that is squared. Now what I'm going to do here is I'm going to take this negative, okay, it's right in line with the fraction bar, but I'm going to bring it up into the numerator. But when I do that, I'm distributing it across, okay, each one of these terms. And so that's going to end up making this a negative 4ac plus a b squared over 4a squared. And then I'm going to just go ahead and rewrite what's over on the left side. 2a squared. Okay. Now what I'm going to do is I'm going to go ahead and rearrange this so we have a positive out here in the front. So this is b squared minus 4ac over 4a squared, and this is x plus b over 2a, and that is squared. Now what I'm going to do is I'm going to square root both sides. So we're going to have the square root of b squared minus 4ac over 4a squared. And of course, if I square root this side here, the 2 goes away, so we're just left with x plus b over 2a. Alright, and I'm going to go ahead and continue this over to this side. So we can go ahead and, oh, about left something off. We got to always remember right, plus or minus when we square root both sides of something. So I just about left that off. Okay, I'm going to go ahead and take this BA to the other side. So we're going to have x is equal to negative b over 2a plus or minus, and I'm going to go ahead and break this square root up. So I'm going to rewrite it in the numerator. So we have b squared minus 4ac, and that's going to be over. Now if I square rooted 4a squared, right, that just becomes 2a. Okay, just becomes 2a. Now we can actually rewrite this one more time. So this is going to end up being negative b, since we have common denominator, plus or minus the square root of b squared minus 4ac, and that's going to be all over this one single fraction. So we have now derived up the quadratic formula, also known as the quadratic equation, because, well, this is an equation here. So it wasn't too bad. And it's probably an exercise that I think everybody should do, and where this thing comes from. But you'll probably have to memorize this, and the best way to do is just work some problems, and that's what we're going to do next. All right. We are going to test it out. See how it works out. So let's bring everything into focus. Move over. All right, and I think we'll start with, we're going to start with, I believe, that first one that I actually wrote up on the board here. And that was the 2x squared minus 11x plus 5. Okay, so remember this was ax squared plus bx plus c is what we started with for deriving up the quadratic formula. So as you can see here, a is equal to 2, b is going to be equal to negative 11, and c will be equal to 5. And of course I'll write it again, so maybe we might have forgotten it already. And that was b squared minus 4ac all over 2a. So what we're going to do is just plug in our numbers. So b is negative 11. Now, best thing to do if you have a negative number, just put parentheses here at first. Plus or minus the square root of, so this is b squared, so negative 11 squared minus 4a, which is 2, and c, which is 5. And that is going to be all over 2a. And now what we need to do is just simplify it down. So we're going to have a negative is a positive 11 plus or minus the square root of, and so we have negative 11 squared, and negative 11 squared is going to give us, I don't know. I just plug all that in the calculator. You know, 4 times 2 is 8, times 5 is 40, 121 I think, minus 40, anyway. Square root of 81, okay? Square root of 81, and 2 times 2 is 4, and that's over 4. So we're going to have x is equal to 11 plus, and the square root of 81 is 9. And of course that's all over 4. And we end up with, what, 20 over 4? Which is 5. And of course, we got to do the other one, 11 minus 9 over 4. And that's going to be 2 over 4, which is equal to a half. Okay? So these are our solutions. 5 and a half are going to be the solutions to our equation. So if you know the equation, it's a whole lot easier doing math than completing the square. Alright? I think it's a lot less steps. Okay. Let's see here. If I can squeeze in another one before my time runs out. 9x squared plus 6x plus 1 is equal to 0. So A is 9, B is 6, and C is 1. Alright. Alright, so I'm going to go ahead and write out the formula again. So you know the real clue is to get this formula down. I should say secret. As you know, just work lots of problems and you'll get it down. That's how all math formulas are. So we're going to go ahead and plug in our stuff. So we have b is 6. We have negative 6 plus or minus the square root of b squared. So I'll just write 6 squared in here minus 4a and c is 1. And it's all over 2a, which is 9. And of course, we just simplify this down. X is equal to negative 6 plus or minus the square root. So after we do the arithmetic in here, let's see, we got 36 minus, it's like 36 minus 36, which is 0, under the radical, okay, over 18. So we end up with negative 6 over 18, and of course that reduces down to negative 1/3. So something I probably haven't mentioned, this has a power of 2 here, okay? So the degree of this is 2, and we would normally have 2 solutions. Either 2 real solutions, could be 2 complex solutions. I don't know, we talked about that yet? Yeah, I think we did. Or it's possible it could just be 1 real solution, or maybe no solution at all, which I guess eventually, no real solution anyway. But the solution is negative 1/3, and what you can do is take negative 1/3, actually plug it in for x here, and see that this whole side, you can prove this to yourself, that this whole side is equal to 0. All right, I'm going to work one more of these. I think call it quits on the quadratic formula. Let's center that up. Let's say we had 2x squared plus 5x plus 7 is equal to 0. So a is going to be 2, b is 5, and c is 7. B plus or minus the square root of b squared minus 4ac. That's all over 2a. And so now we go plugging stuff in, move everything over a little bit. So that'd be negative 5 plus or minus the square root of b squared, which is 25, minus 4a and c over 2 times, oh, no, that's a, it's 2 times 2. Getting in a hurry there. So we end up with x is equal to negative 5 plus or minus the square root. Now let's see, 2 times 4 is 8, and 8 times 7, let's see, 625 minus, that's going to be minus 31. So we're getting a negative under the radical here, which means that we have a complex solution, and 2 times 2 is 4. So we're going to end up with x is equal to negative 5 plus or minus I square roots of 31. Okay, and I'm going to go ahead and put the 4 here, break this up, the 4 here, so we have the real part and then the complex part over here. So this is going to be your solution, and remember, of course, there's 2 of them. You got negative 5 fourths plus I times square root of 31 over 4, and then you have negative 5 fourths minus I. So this is a complex solution, but not a real solution. Okay. And I think that's going to end that, and hopefully you got the quadratic formula down.